the limits by Stu stuff. So Jake has a question. Which one? The last one on the very last page. Number 12, this one. All right, so it says if the limit as x goes to -2 of 3x cubed plus 10x squared plus 4x plus k all over x squared plus 4x plus 4 exists, find the value of k. All right, so you can try to factor, but you kind of have this value of k that's happening, right? So it's a little tricky. So did anybody feel like they got the right answer? All right, so you're going as you approach -2, so you can't just plug in -2. What do you think?
I used synthetic division.
All right, so what do you use for your synthetic division? Good. So when you factor this, you see it's x plus 2 times itself squared. Did you guys get that? So what he's saying is that he did synthetic division with 3, 10, 4, and k, and you put -2 in. Because you know that if that limit is going to exist, it's not going to be like, probably not like an asymptote or anything. It's probably a whole, right? It probably divides evenly. So when we do that, we get -6, 4, -8, -4, and then we get 8. So we want k plus 8 to equal 0. So what should k be? -8. That's exactly what it is.
I got this by plugging it in.
Well, what do you mean by plugging it in? Because the bottom is 0. Oh, you wanted a 0 out, so you thought, oh, it should be in the form 0 over 0, maybe?
I mean, like, I took -8 and plugged it in for k and see if it works.
Okay.
And it was helpful.
With synthetic division? With division or something?
But now it's
Okay.
Yes.
All right, yeah.
I did it a different way. Instead of equal to 0, and then I got the denominator out of the way.
Yeah, so she knew that it was going to be like 0 over 0, so she got the numerator and she wanted to find when it was equal to 0 when she plugged in -2. You could do that as well. So, Charles, I think what you're saying is it was a starred problem, so you used your calculator and did a table of values. Is that what you did?
No, what I did
Because-
was I took the problem, the 3x cubed plus 10x squared, etc., and plugged in -8 for k because that was one of the options.
Uh-huh. Okay, but how did you know that that limit went to negative, or went to something?
I mainly just looked at the graph.
Okay. All right, so you use your calculator. All right, so what else? Number 10?
5.
I heard number 10 first. All right, so which of the following limits does not exist? Did you graph each of them? Well, I mean, it's one graph, right? So I would say go ahead and graph it. Ah, good question. How do you graph an absolute value? If you hit math, so you're going to go to y equals, and you have 2 divided by x, minus 2 divided by the absolute value. So you're going to do math, number, absolute value, x, and then you hit graph, and it looks a little funny. All right, so we have that. That seems weird, doesn't it? I feel like I should have something over here too. Oh, well, it ends up being 0 actually. So for x values that are positive, do you guys see how these would be exactly the same thing? So it would end up being 0, so it's not graphed, it's right here. All right, so your graph is kind of funny. So it's looking like that. Oops, going along there, and then it's looking like that. All right, so which of the following does not exist? So as you approach 0 from the right, does it exist? Yeah, I think it goes towards 0, right? Yeah, so this is 0. The limit as you approach 0 from the left, that's -infinity, so that would be a does not exist one, right? And then as you approach 0 in general, that's does not exist. So you got to be careful. You have to remember that -infinity is technically a does not exist one as well. So which of the following does not exist? It would be 2 and 3. So D. All right, and then I heard a couple people say number 5. Okay, this is one of those horizontal asymptote ones.
Not that 5.
Not that 5? Okay. A different 5. Oh, this one? I had a lot of people text me about this one. All right, so we have the limit as x goes to 3 of f of x equals 5 over 2. Can you plug in 3? Do you get 0 in the denominator? Nope. So plug in 3. So I have a times 3 squared plus a times 3 plus b all over 3 squared minus 1. And this is all going to equal 5 over 2. So we end up getting 9a plus 3a plus b all over 8 equals 5 over 2. Multiply the 8 over, so we get 20 on the right side. And we have b plus 12a. And it says find b in terms of a. This is just like saying find y in terms of x, right? Solve for y in terms of x. It means get like the y by itself. So in this case, we're getting the b by itself. So your b equals 20 minus 12a. That should be your answer. So a is still in your answer. Now part B, you're actually going to use part A, and I think he probably should have been a little bit more clear. So we're finding the values of A and B, and in order to find the values of A and B, we need 2 equations. All right, so if I have the limit as x goes to -3, well, that means that I'm going to have A times -3 squared plus A times -3 plus B all over -3 squared minus 1. So I get 9a minus 3a plus b all over 8. And this time it's equal to 1, right? So I have 9a minus 3, well, let me combine those. I get 6a plus b is equal to 8. So in order to solve for a and b, we need 2 equations that have a and b. Well, that's where we're using part A, right? So we have 2 equations, so we're going to replace b with 20 minus 12a. So we're going to have 6a plus 20 minus 12a equals 8. So I get negative 6a plus 20 equals 8. Subtract it over. So I get a is equal to 2. And then once you have a is equal to 2, what's b equal to then? Yeah, plug it in. 20 minus 12 times 2 is going to be 24. So 20 minus 24, negative 4. Those are your answers. All right, I don't think I can scroll down without my things are going to move. I'm going to clear this ink. Are you guys good? Clear? All right, and then C. So these are, one of them's a horizontal asymptote one is a factoring, seeing if there's a hole. So he says find the limit as x goes to x goes to 1. So let's try to factor. So in the numerator, I can pull out a 2. So I have x squared plus x minus 2 all over denominator x plus 1, x minus 1. And then the other one's a horizontal asymptote problem, right? So what's the limit as x goes to infinity? Yeah, so it's going to be 2. Did you guys see that? Because we have 2x squared over 1x squared. So 2 over 1 is 2. All right, so we're still working on this part. So I have the limit as x goes to 1, and I have 2, and then I'm going to have x minus 1 times x plus 2 all over x minus 1 times x plus 1. So if you still aren't very good at factoring, which by this point in calculus I think you should be, but we know it's the limit as x goes to 1, so it's probably going to have x minus 1 as a factor. That usually helps. So x minus 1's go away. Now can we plug in? Sure. So I have 2 times 3 all over 2 minus 2. So you get 3 minus 2, which is 1. Did anybody get that?
Yeah.
Good. All right, that was your last question. The rest you got to figure out later. You can bring this to me at the end of the day if you need to. Talk to your friends. Compare answers.
What is number 4?
I don't know.